Okay, so today we're taking a deep dive into quantum computing, which,
Sounds exciting.
yeah, it really is. We've got this glossary of terms here.
A lot.
That's a lot, right? Don't worry, though. We're going to break it all down and figure out what's really interesting and what the coolest parts are. What do you think, just looking at this list as a whole?
Well, I think it's pretty amazing to see just how much ground this list covers.
Oh,
We've got the foundational stuff like superposition and entanglement, which, those are like the core principles.
right.
But then we also have terms about actual applications like quantum machine learning, even specific hardware like
Yeah,
different kinds of qubits. It just shows how fast this field is moving from theory to,
reality.
yeah, reality.
Yeah, it's pretty wild. So maybe we could start with some of those foundational terms. I'm kind of stuck on superposition, entanglement, and qubits. Those sound pretty,
Complex.
yeah, complex.
Yeah, they are the basics, the building blocks of this whole quantum world. So think about this. Imagine a single atom, okay? And this atom can exist in two different energy states, but it's doing both at the same time.
Wait, what? How is that possible?
That's the magic of quantum mechanics. It's like that analogy of a coin spinning in the air?
Yeah,
Before it lands, it's both heads and tails at the same time, in a sense.
right.
That's kind of like superposition.
Oh, wait.
It's not until you stop it and look at it that it becomes one or the other.
Gotcha.
And that's what qubits can do. That's what makes them so powerful.
So qubits are like the quantum version of bits.
Exactly. In a regular computer, a bit is either a 0 or a 1.
Yeah.
But a qubit, because of superposition, can be both 0 and 1 at the same time. It's mind-bending, but it's what gives quantum computers their edge.
Okay, so instead of just 0 or 1, it can be both. That is mind-bending. And what about this entanglement? How does that fit in?
Entanglement. Now, this is where things get really wild, and even Einstein had trouble wrapping his head around it.
I can imagine.
Basically, when two qubits become entangled, their fates are linked, no matter how far apart they are. Imagine you have two of these coins, both spinning.
Okay.
They're entangled, right? If one lands on heads, the other one instantly becomes tails, even if they're miles apart.
No way.
That's entanglement. Einstein called it spooky action at a distance.
Spooky is right.
But that spookiness, that's what makes quantum computing so powerful. Because these entangled qubits can influence each other instantly, they can perform calculations in a way that classical computers just can't.
So it's not just about individual qubits being in multiple states. It's the fact that they can be linked together in this crazy way.
Precisely. That interconnectedness is key to unlocking the potential of quantum computing. That's why we're so excited about this technology.
Okay, I think I'm starting to get it. So we have these powerful qubits. They're linked by entanglement. But how do we actually use them to solve problems? That's where quantum algorithms come in, right?
Absolutely. Quantum algorithms are like regular algorithms, but,
Superpowered.
Exactly. They're specifically designed to take advantage of these quantum properties to tackle problems that would take classical computers, even the most powerful ones, practically forever.
So we're not just talking about faster calculations, but about solving entirely new types of problems.
Exactly. Problems that are impossible for classical computers to solve no matter how long they run. Think about simulating the interaction of molecules to design new drugs or materials,
Yeah, okay.
or optimizing complex logistical systems, or breaking the encryption that protects our online data.
Whoa.
Those are the kinds of challenges that quantum algorithms are designed to address.
And I see quantum machine learning on here too.
Right. Think of all the data we generate every day. Financial transactions, social media posts, sensor readings. Quantum machine learning could analyze this data in ways we can't even imagine right now, uncovering hidden patterns and insights that could revolutionize everything from financial modeling to medical diagnosis.
It's crazy to think how much data we have and how much more powerful the analysis could be with these quantum algorithms.
Yes.
So this all sounds amazing, but you're building these quantum computers, it can't be easy. I mean, what are some of the challenges? The list mentions superconducting qubits and trapped ion qubits.
Yeah, building quantum computers is one of the biggest engineering challenges we face, honestly.
Makes sense.
I mean, think about it. We're trying to control the behavior of individual atoms. It's delicate work.
Wow.
Superconducting qubits and trapped ion qubits represent two different approaches to building the hardware. Each has its pros and cons, and it's a really hot area of research right now.
So it's kind of a race to see which technology will win out.
Yeah, pretty much.
And I see quantum noise reduction and quantum error correction on the list too.
Ah, yes, these are big ones. Because quantum states are so fragile, any tiny disturbance can cause errors in the computation. Even like the slightest vibration or change in temperature can mess things up.
Really?
Yeah, it's that sensitive. So, a huge part of building practical quantum computers is figuring out how to reduce this noise and develop error correction techniques to make them more reliable.
So as amazing as all this sounds, we're still quite a ways from seeing like widespread use of quantum computers, right?
That's fair to say. We're still in the early stages.
But the potential is clearly huge. So what's the main takeaway you want our listener to walk away with today?
I think the biggest takeaway is that quantum computing is a rapidly evolving field with mind-blowing potential. It's not just about faster computers, it's about completely new ways of solving problems.
So definitely something worth paying attention to.
Absolutely. While we may not be teleporting ourselves anytime soon, quantum technologies are already being developed and will only become more prevalent in the years to come. This is just the beginning.
Awesome. It's exciting to think about all the possibilities and, it just goes to show that sometimes the most complex things can also be the most beautiful.
Absolutely. The universe works in mysterious ways, and it's up to us to keep exploring and pushing the boundaries of what's possible.
Well said. That's all the time we have for today's deep dive. But for all you listeners out there, keep an eye out for quantum computing in the news. It's sure to be a wild ride.
Definitely will be.
Until next time.
See you then.